Hello everyone. Yeah. Today we are going to discuss the practice problems of tetrahedron and cone. So here is the example of the tetrahedron. ABCD is a tetrahedron of 60 mm long edge. The edge AB is in the HP. The edge CD is inclined at an angle of 30 degree with the HP and 45 degree with VP. Draw the projections. So here is the example of the tetrahedron. ABCD is a tetrahedron of 60 mm long edge. Here the height of the axis is not given because we all know that tetrahedron is a solid bounded by 4 equilateral triangles. So if the length of the base edge is 60, the length of the slant edge will be equal to 60, or the length of the each slant edge will be equal to 60 and length of each base edge will be equal to 60. So right now ABCD is a tetrahedron of 60 mm long edge and the edge AB is in the HP. So we have to take the edge AB on the right hand side and we have to draw the tetrahedron like this: AB, BC, CA, and after finding the center we have to mark the plan of the point D. So first of all, draw an equilateral triangle in the top view, AB, by taking AB on the right hand side. So after drawing AB, mark point C, because the top view will be an equilateral triangle of 60 by 60 by 60. So after marking point C, draw ABCD, mark the center. As we all know that how can we find the center? To find the center, we have to measure the midpoint of one edge and join the that point to opposite corner. Thereafter measure the midpoint of the another edge and join the opposite corner. The intersection of these two edges will give us the top view of the point D. Now let us say that ABC is the base and D is the apex point. So DA, DB and DC are the slant edge. Now take the projection along XY line. So this will be the base, A dash, B dash, C dash. Project the take the projection of the axis from D. Now here the axis height is not given, but we all know that the length of each slant edge is equal to 60. But here we have to measure CD is equal to 60 because in the elevation only CD will give us the true length, because the plan of CD is parallel to the XY reference line. So first of all, draw this projection. Then after measure 60 mm, give an arc from C dash on the line of the axis. It will give us the D dash. Then after connect D dash to C dash and D dash to A dash B dash, it will be the elevation of the tetrahedron. So after drawing the top view and front view in the first stage, now we have to draw the second stage, or we have to derive the second stage. And as the tetrahedron is resting on HP, in the second stage we have to derive the condition with the horizontal plane. And here it is given that the edge CD is inclined at an angle of 30 degree to HP and it is also inclined at an angle of 45 degree to VP. So in the second stage we have to take the condition edge CD inclined at an angle of 30 degree to HP, and in the third stage we have to take the condition edge CD inclined at an angle of 45 degree to VP, because edge CD is inclined at an angle of 30 degree to HP and 45 degree to VP. Now if the inclination of the base is given, or inclination of the axis is given, or the inclination of this particular triangular face is given, this particular triangular face D dash, A dash, B dash is given, then we can easily redraw this figure over here. But here right now the angle of CD is given, so it is typical for us to copy this figure over here. So for that we have to derive another point in the elevation. In the first stage we have to draw a line perpendicular to line to line C dash D dash from A dash B dash. So draw a line perpendicular to C dash D dash from line A dash B dash. Why it is required to derive these points? Because as we have discussed that if the angle of base is given, or if the angle of x is given, or if the angle of this edge is given, we can easily incline it in the second stage, because we have to take A dash B dash on the xy line. So this is the case. Because we have to take the A dash B dash on xy line, we have to make the inclination of CD. We have to derive these points. So draw a line perpendicular line C dash D dash, perpendicular to the line C dash D dash from A dash B dash, and mark that point as E dash. Now if we want to copy this figure over here, if we incline this edge A dash B dash to E dash at an angle of 60 degree, then we will get the angle of C dash D dash equal to 30 degree, because right now this edge and this edge are perpendicular to each other. So if we incline this edge at an angle of 60 degree, then we will get the angle of C dash D dash equal to 30 degree. So for that, measure 60 degree angle, measure 60 degree angle like this, and mark E dash point on that particular line, E dash. Now draw a line perpendicular to this line A dash B dash 2 dash from E dash. So we have to draw a line perpendicular to this line, perpendicular to this line from E dash. After drawing this line, take a measurement E dash to C dash and give an arc on that line. It will give us C dash. Measure E dash to D dash and give an arc from this point. It will give us D dash. And then after copy this figure. After copying this figure, now take the projection C dash A dash B dash from D dash. Take the projection from plan A, C and D and B. Mark the points A, B, C and D. After marking these points, now we have to draw the plan in the second stage. And to draw the plan in the second stage, we have to derive any of the one cases that we have discussed earlier. That is case 1, case 2 or case 3. And here we are going to apply the case 1, because here the points are not rotated, and also this edge is not up to the perpendicular. The angle of this edge is more than 90 degree. You can easily observe that the angle of this edge is more than 90 degree. So we are not going to apply the second case. And here in the plan, the points are also not get rotated, so we are not going to apply the case 3. So we are going to apply the case 1, in which we have to observe the figure from the observer side, and you can see that if you are watching this figure over here, the D dash C dash edge is going to be visible, DA is going to be visible, and DB is going to be visible, and AB is going to be hidden. You can observe that AB is hidden. DC, DA, DB is visible, and AB is hidden. So make DA, DB and DC, AB, CB visible, and AB is going to be hidden. You can also draw A1, B1 as a hidden outline, because it will intersect the HCD, which is the visible outline. So this will be the plan in the second stage. Now we have to derive the third stage, in which we have to incline HCD at an angle of 45 degree to VP. HCD, not the plan of HCD, not the plan of HCD. We have to incline HCD at an angle of 45 degree. So measure CD. It is the true length of CD. So CD, mark CD. The green line will show us CD. Now draw a locus from D point. Let us say that this is D dash, this is C dash. So now draw locus from C dash and D dash, and now measure D1 C1 and give an arc from C on that locus. It will give us D1. Now mark this point as C1 D1 and copy this figure over here, as we have C1 D1 C1 D1 already here. Now copy this figure like this, measure D1 to A1 and B1. So D1 to A1 B1, and then after C1 to A1 and B1, C1 to A1 and B1. Copy this figure over here. That means the visible outline will remains visible and hidden outlines will remains hidden. Only the thing is that we have to find out the angle beta for C1 D1. So here is the angle beta. For that we have measured C dash D dash at an angle of 45 degree. Then after we have drawn the locus, then after we have measured C1 D1 and we have given arc from this point upon the locus of D. It will give us D1. So this is C1 D1. We draw this figure as we have discussed. Now draw the elevation. Now here again we can see that D is our apex point for this figure. So D is nearer to VP, so it is nearer to XY line. So we can say that it is nearer to VP. So if apex point is nearer to VP, base will be nearer to the observer, and if base is nearer to the observer, in the elevation base is going to be visible. So now project the base A, B, C and draw the base as a visible part because base is going to be visible. Now project D dash. Now join DC, DA, DB by applying the rule of intersection of the visible outlines and hidden outlines. So D1 C1 is visible, D1 B1 is going to be visible because in between D1 B1 we doesn't have any visible outline. In between D1 and C1 dash we doesn't have any visible outline. And whenever we will join D1 dash A1 dash, this is A1 dash. So D1 dash A1 dash is going to be intersected at C1 dash B1 dash. So it is going to be hidden. Now project the axis. Here is the point of the axis, and draw the axis. So this is it for the tetrahedron, and this is the third stage in which we have applied the rule that the base is nearer to the observer to draw the elevation, and in the second stage to draw the plan we have applied the case 1. Now next example, this is the example of the cone. So here it is given that a cone diameter of base 60 mm and height 90 mm is resting on HP on a point of the periphery of the base. Axis of the cone makes an angle of 60 degree with HP and 30 degree with VP. So the axis makes an angle of 60 degree to HP and 30 degree to VP. So for the angle of inclination with HP we have to incline the axis, and to show the angle with VP we have to incline the axis again. So in the first stage the cone is resting on the periphery of the base, or on the point of the periphery of the base. So it is going to rest like this on the point of its base. So in the first stage we have to draw the cone like this, circle, 8 division of the circle, and to show the apex point we have to join the divisions, and we have to show the generators of the cone. We all know that generators are the imaginary lines. So first of all in the plan draw the circle having radius is equal to 30 mm because the diameter of the circle is 60 mm. So draw the circle having radius is equal to 30. Then after divide the circle into 8 equal parts, and to divide the circle into 8 equal parts measure the radius, give an arc, join the intersection of these two arcs, join the intersection of these two arcs to the center. It will divide the circle into It will divide the circle into 8 equal parts. Again, take two intersections, join this point to the center. It will divide the circle into 8 equal parts. First of all, we have to draw horizontal and vertical diameter which are perpendicular to each other. Then we have to divide the circle into 8 equal parts by using the particular method. Now mark the points A, B, C, D, E, F, G. It will be the base of the cone. This will be the apex point. And OA, OB, OC, OD, OE, OF, OG are the generators. Here we have drawn the generators as a continuous thin line, because as you know that cone doesn't have any edge and the generators are imaginary lines. Now to draw the elevation, project A, BH, CG, DF, E. So this will be the base in the elevation. A dash, B dash, C dash, D dash, E dash, F dash, E dash, H dash. This is the base in the elevation. Now project the axis, apex point, measure the axis 90 mm, mark the axis or elevation of the axis, join the elevation of the axis to the base points or to the points of the base. So these are the generators. So O dash, A dash, O dash, B dash, O dash, C dash, O dash, G dash, O dash, E dash, O dash, F dash are the generators. Now in the second stage, as the cone is resting on HP, we have to derive the condition with the horizontal plane. So in the second stage, it is given that axis makes an angle of the cone makes an angle of 60 degree with HP. So if you want to incline the axis at an angle of 60 degree, here the angle is 60 degree, not 30 degree. Okay, 60 degree. So if you want to incline the axis of the cone at an angle of 60 degree, we have to incline the base at an angle of 30 degree. So incline the base at an angle of 30 degree by marking the point A dash on XY line, because it is going to rest on that point on HP. It is the point of the periphery of the base. So A dash, measure the angle equal to 30 degree of the base and mark the base. A dash to E dash. Copy this figure over here. A dash to O dash, A dash to O dash, E dash to O dash is going to be remains same, equal. Mark O dash, mark the points of the base on the base. A dash to D dash F dash, A dash to D dash F dash, and E dash to B dash H dash, E dash to B dash H dash, and also the C dash G dash. Mark the points, take the projection from these points of the elevation in the vertically downwards, and take the projection or draw the locus from these points horizontally in the right hand side. So O dash, O1, A dash, A1, B dash, B1, and H1, G and C, so G and C, T and F, and E. Mark the points. Draw the freehand curve joining the points of the base. Then after, see here we are going to draw the visible outlines of the base only. We are not going to show the hidden outlines of the generators, because as we know that cone doesn't have any edge and the generators are the imaginary line. So now in this figure, only the part of the base is going to be visible or hidden. So some part of the base is going to be visible and some part of the base is going to be hidden. So now we have to find out that which part of the base is going to be visible and which part is going to be hidden. So first of all, drawing the freehand curve from the base. Then after drawing the freehand curve from the base, draw the tangent to the curve of the or draw the tangent to this curve from O. So now here is the tangent to the curve, and we will get the tangent over here at this point. Now observing from the top, we all know that OE, the generator OE is going to be visible, and the part from OE, OD, OC, from the part O to E, O to D, O to C, O to F and O to G is going to be visible. So this part is, or this curvature is going to be visible as observed from the top. As observed from the top. So if we observe from the top, this surface of the base is going to be visible, or the periphery of the base is going to be visible. So now from this tangent, the outside curve is going to be visible, and the curve inside from this point is going to be hidden. And if you want to show the generators, we can also show the generators, but not visible or not hidden, okay, because generators are not the edge of the cone, generators are the imaginary lines. So it is not necessary to show the hidden generators. Now copy this figure over here, and if we want to copy this figure over here, first of all we have to apply the given data, that is axis makes an angle of 30 degree with VP. Now here again it is given that axis makes an angle of 30 degree to VP, not the plan of the axis. So if we will give the name of the plan, it is O1 N1, not the plan of the axis. Here it is given that axis makes an angle of 60 degree with HV and 30 degree with VP. So axis is going to be inclined at an angle of 30 degree. So we have to measure the true length of the axis. So we can measure it from here also and here also. Draw the angle of 30 degree and mark the true length of the axis. Measure the true length of the axis and mark the true length of the axis over here on this line. Now measure the plan of the axis. As you all know that we have to draw the plan over here, and if you want to draw the plan, we have to find out the angle beta for the given edge, and here the edge is the axis. So for axis we have to find out the angle beta. Now measure O1 and 1, give an arc from here, it will intersect over here, and the angle beta will be 90 degree. Here the axis makes an angle of 30 degree to HV, so theta is 60 degree and phi for the axis is 30 degree, and theta plus phi is equal to 90 degree. So we have got beta is equal to 90 degree. As we all know that theta plus phi is equal to 90 degree, then beta is equal to 90 degree, and you can also say that alpha is equal to 90 degree. And here if you measure the alpha angle of the axis, it is also the 90 degree. Now copy this figure over here by marking O1 and 1. How can we copy this figure over here? Now see, we have the line of O1 and 1, so we can mark O1 E1. So mark O1 E1, so this is E1. We can also mark O1 A1, so mark O1 A1, and on this line perpendicular to this line mark G1 and C1. So this is C1, G1. If you want to mark this F1 and B1 and H1 and B1, so we have measured it from E or A to H, A to B, E to F, E to D. So A to B, A to H, E to D and F. Now mark or measure F, that means we have taken the cross measurement. Now A to F, A to D, so A to D, A to F, and same from E to H and B, so E to B and H. Mark the points, copy this figure over here. Same, visible will remain visible and hidden edge will remain hidden. So again, if you want to copy this figure, first of all draw the curvature of the base. We have to draw the tangent like this, show the tangent, and draw the outer curve from the point of the tangent as visible, and the inner part of the curve from the tangent is going to be hidden. Now here I think you have a question in your mind, why we have take the apex point away from VP, because here it is given that draw the projection of the cone when apex is nearer to the observer. So we have to take the apex nearer to the observer. In all the problems that we have done earlier, we have taken the apex away from the observer and base nearer to the observer, but right now in this question we have taken apex nearer to the observer. Now if base is away from the observer, base is not going to be visible, or whole part of the base is not going to be visible. Now how can we define that part? First of all, take the projections A, E and O. So A, E and O. Then after G and C, G and C, B and H, so B and H, and E and D. Mark the points first of all, A, B, C, D, E, F, G, H and O dash. Now whenever the base is away from the observer, how can we draw the elevation? So for that, first of all find out the leftmost and rightmost point from the base. So this is the leftmost point and this is the rightmost point. To mark that points in the elevation, that is C1 dash, G1 dash. Now from these 2 points, the part of the base nearer to the observer is going to be visible. So from these 2 points, what we have done, we have find the leftmost point and rightmost point, and we have marked that in the elevation. Now what we have done, the part of the base nearer to the observer from these 2 points is going to be visible in the elevation. So we can see that B, A, and G. So B, A, and G, this part of the base is going to be visible. So draw this part as a visible part. Join O dash to C and G. Now here it is not required to draw the tangent because we doesn't have the deep angle. So the part of the base nearer to the observer is going to be visible, and part of the base away from the observer is going to be hidden. That is, from these 2 points, this part of the base in the elevation is going to be hidden, and this part of the base in the elevation is going to be visible. So these are going to the visible generators. O1, C1, O1, B1, O1, A1, O1, H1, O1, G1 are going to be visible. It is not required to draw the hidden generators because we all know that generators are not the edge of the cone and generators are the imaginary lines. So this is it for the cone. Thank you.